In this lesson, we're going to learn to find the area of parallelograms. We're also going to learn about finding a missing base or height if we know the area.
How do you find the area of a parallelogram? In this lesson, you will learn how to find the area of a parallelogram by decomposing into a rectangle. Let's review. When we find area, we are finding how many square units can fit in the shape. So you see down below we have a rectangle, and if you take a look, we have little squares within that rectangle on our unit grid. In our first row, we have 8 squares. In our second row, we have another 8, which brings us to 16. Then we have another 8, which brings us to 24. And then another 8, which brings us to 32. So our area for that rectangle would be 32 square units. Let's review. You find the area of a rectangle by multiplying length times width. So instead of just counting up all the squares that are within that rectangle, we can also find it by multiplying our length, which is our bottom, by our width, which is our side. And again, we have our length as 8, our width is 4, so 8 times 4 equals 32. And much like our last rectangle, which is congruent to this one, we have an area of 32 square units. A common mistake is that students often multiply 2 sides of a parallelogram to find the area. So for our parallelogram down below, we have 2 sides, which are highlighted in purple, and those 2 sides are often multiplied to find our area. That is actually an incorrect way of finding it, and it will not give you the correct area. Let's take a look at a parallelogram. For our parallelogram, we have our bottom, which is referred to as our base, and instead of our side, we're going to find our height. Now, our height actually has to be perpendicular to our base, which means that it forms a right angle, and it has to extend all the way to the top of our parallelogram. So our base runs along the bottom of our parallelogram. Our height runs along the side of the parallelogram all the way up to the top, and it has to form a right angle with our base. So now let's try an example. Here we have our parallelogram, and what we're actually going to do is we're going to decompose this parallelogram, which means that we're actually going to break it up into pieces to help us find the area of it. Now, what you'll find is if we take our parallelogram and we split it in half, and we actually take one side of that and slide it over, well, now you see a shape that you're very familiar with. Now we have a rectangle. And as we reviewed earlier, you can find the area of a rectangle by multiplying the length times the width. So we have our length, which is 7 units, our width, which is 4 units. 7 times 4 is 28. And then, of course, those are square units. Again, we're measuring the amount of squares that can fit within that rectangle. So we have 28 units, and of course, again, that was for our parallelogram, which we decomposed to make into a rectangle. In this lesson, you have learned how to find the area of a parallelogram on a grid by decomposing a rectangle.
So let's give it a try. We're going to go ahead and find the area. Now, one thing we have to be careful about is that in a parallelogram, there's usually going to be more than just the 2 dimensions, the base and the height. So we have to identify the base, and then we need the height, and that is the measure of how far away the other base is from our base. And it's a perpendicular distance. So I will highlight in yellow. Here is our base, and here is our height. So we'll use this formula. Area is equal to base times the height. So we substitute in the numbers that we know. 2.5 meters times 1.8 meters will give us a total area of 4.5 meters squared. So notice this 2 over here was just kind of extra. We didn't need that. If it were a rectangle, if this angle right here were a right angle, that would be the width of the rectangle, but it's not. So remember, you kind of almost have to visualize being able to cut right along this line and sliding that over so that the 2 diagonal edges would meet, and then you would have a rectangle that has a length of 2.5 equivalent to the base and a width of 1.8 equivalent to that height. So if I give you one of the dimensions, like the base, and I give you the area but not the height, so this question mark right here stands for the height because it is the perpendicular distance. So we use the formula, area equals base times height, and we substitute in what we know. So 24 square centimeters is equal to 4 centimeters times the height. So if I divide both sides by 4 centimeters, I would find that the height will be equal to 6 centimeters because 24 centimeters squared, remember that's a centimeter times a centimeter. This centimeter squared is centimeter times centimeter. So one of those centimeters will cancel with here, and the other one becomes the unit of our height, which is a one-dimensional unit.